This is the second video covering 9.2 and the last video for chapter 9. So in this video, we're going to look a little bit more at quadratic inequalities in one variable. The first video for 9.2 went over how to solve these things graphically. This one's going to focus more on how to solve them algebraically. So our first one that we're going to look at is actually the same thing we did for the first one in the last video, which is solving x squared plus 6x plus 5 less than 0. So we got the same inequality here, but we're going to try to solve it a slightly different way. So to solve this thing by graphing, we are still going to kind of keep a graphing mindset. So we're going to start by figuring out where our x-intercepts are, because you might remember from the last video, the x-intercepts were really important. They were sort of our boundary points to our solutions. So we do still need to know where those x-intercepts are to be able to get our answers. So the way we're going to find those x-intercepts is by solving the corresponding equation. So we're going to ignore the inequality, and we're just going to solve x squared plus 6x plus 5 equals 0. So remember, this is what we did in chapter 4 as well, right? So when you set it equal to 0, that's going to be your x-intercepts, your solutions, your roots, your zeros, whatever you want to call them. X squared plus 6x plus 5, that's pretty easily factorable. So that's going to get us x plus 5 times x plus 1, which is going to get us our solutions, or our x-intercept at least, at x equals -5 and x equals -1. So in the last lesson, we would have graphed this, right? So I'm just going to draw a really quick sketch to help us visualize things. And we had intercepts, in this case, at -1, -5, somewhere over here. And we had a graph that goes up like this, right? And so we know it goes up just because of the a value. I don't really care about the vertex. I don't really care about any specific points. I'm just using this as sort of a visual guideline. So looking at this, we can see that our x-intercepts break our parabola up into 3 pieces. And so our question is really, well, which of those pieces are the ones that I actually care about? It might be 1, it might be 2. So which ones do we actually want? So I'm just going to color code them here just to make our conversation a little bit easier about these. So we're going to have the green piece over here on the left, the yellow piece in the middle, and then this pink piece on the right. So just to help us visualize things a little bit more clearly, let's draw ourselves a number line. I'm going to draw a proper number line this time, but in general, it's going to be just a really quick sketch of a number line. So let's get ourselves a line that goes from, say, -8 to +2, give or take. All right, and so our x-intercepts that we just found at -5 and -1, so right here and right here, they break my x values, my domain, up into 3 pieces. And so we had the green piece on the left, the yellow piece in the middle, and the pink piece on the right. And so those colors just correspond to what we had here, right? Let's talk about the domains here for a second. This is something that you are going to have to do on a regular basis. You're not going to have to necessarily do every single piece, but just knowing how to do them is pretty helpful. So the piece on the left here, these are all the x values that are less than, right, smaller than -5. The bit on the right is all the x values that are bigger than -1. And then everything in the middle is everything in between those two values. So everything where -5 is less than x, which is less than -1. So those are our sort of our 3 possible parts to our answer. Because remember, when we were looking at this in the last video, our answers always ended up being domains. And so we just have to decide which of these domains is going to be the one, or the ones, because there could be more than one, that we want. So to find our solution region or regions, we're going to do something that we have done a fair bit of in this chapter, which is test some points. But in this case, we're not testing y values, we're just testing x values. So we're testing one x value from each of those 3 sections on our number line. And so it's going to be up to you to pick whichever number you feel is sort of the easiest. It doesn't really matter. Just pick any x value from each of the regions and test them with the inequality. So in this case, if I'm testing something from the green region, I'm going to go with, let's say, -6. From the yellow region, we'll go with -3, and from the pink region, we'll go with 0, because remember, 0 is always nice. So our inequality was x squared plus 6x plus 5 is less than 0. And so I've got 3 things to test here instead of the 2 that we saw before, so I'm just going to kind of split this up into 3 sections just so I can organize things a little bit more nicely. So my first section was when x was less than -5, right? So that's the green section up top here. My middle section, -5 is less than x, which is less than -1. And then my right section, x is greater than -1. You don't have to fully set this up and clearly label everything like this. It doesn't really matter that much, but it's okay. So for my section on the left, I'm going to test x equals -6. In the middle, I'm going to test x equals -3. And the right, I'm going to test x equals 0. So if we plug all those things in, so for the one on the left, we end up with -6 squared plus 6 times -6 plus 5. And if this is the section that works, we should end up with that all being less than 0, if it fits our inequality. Well, -6 squared is 36. 6 times -6 is -36. 5 is just 5. And if you add all that together, you end up with 5 being less than 0. So that's no good. If we test this section in the middle, we do the same thing with -3 now. So we got -3 squared plus 6 times -3 plus 5. Well, -3 squared is 9. 6 times -3 is -18. And we've still got the 5 there. So if you add all that together, that's going to get you -4. And -4 is less than 0. And so we do the same thing with our x equals 0, our value from, again, the pink section. So if you plug 0 into all of these things, we end up with 0 squared plus 6 times 0 plus 5. And you can probably see where this is going. 0 and 0 and 5 is just going to get you 5. And once again, 5 is not less than 0. So what we've got here is 3 sections. The one on the left did not work. Green was no good. The one in the middle, the yellow, was good. And then the pink one on the right was also no good. All right, and so our solution is just going to be the x values from the region that got us the thing that worked, which in this case was the middle. And so we've already done all of the labor to get our answer already set up. So it's just going to be these domains up here. So we had this green domain, that one didn't work, this yellow domain, which did work, and this pink one, which didn't. So it's just going to be that one that we highlighted in yellow. And so our answer is -5 is less than x, which is less than -1. And there we are. And so that is your general process, right? You figure out your x-intercepts, you set up some of your 3 regions, usually 3 regions, you test some points, and you figure out which ones work. So let's try another one and see how it goes. So we've got -3 x squared plus 5 is less than or equal to 2x. So if we're going to be solving this, remember for quadratics, we do need everything to be on the same side of the equation, or in this case, the inequality. So our first step should be to move all terms to one side. So we need to make sure this thing equals to 0. So we've got, if we move that 2x, -3x squared minus 2x plus 5 is less than or equal to 0. Now we want to solve to get the intercepts. And so this thing is factorable. So let's go ahead and factor it. So we want 2 things that multiply to -15 and add to -2. That's going to be -5 and +3. So we're going to get -3x squared plus 3x minus 5x plus 5 equals 0, right? Not less than 0, because we're trying to solve for intercepts right now. And then we go through the whole factoring bit. And so when we do this, we're going to get our two factors of x minus 1 and negative 3x minus 5. And so our two solutions, our intercepts, are at x equals 1 and x equals negative 5 over 3. And that's great. You might have had an easier time of this, by the way, if you had moved everything to the right instead of the left. It would have been totally valid. I chose not to because I didn't feel like it. But you wouldn't have had this negative on the x squared if you had moved everything to the right side instead. You also could have chosen to solve this with a quadratic formula. Would have been totally valid. So we noticed that it was factorable, but you don't need to solve by factoring if you don't want to. Any way of solving will work. All right, so I'm going to sketch myself a really sloppy number line this time, so I don't need to properly label all the different numbers. I don't really care all that much. I only really care about the intercepts. So I'm just going to draw myself a quick line. My intercepts were at negative 5 over 3 and positive 1. And so that splits all my x values up into 3 sections. So the section on the right is all the x values that are greater than or equal to 1. My section in the middle is all the x values that are less than or equal to negative 5/3. And that's how this is always going to work. So the section on the left is always going to be less than your smaller x-intercept. The section on the right is always going to be greater than your larger intercept. And then the section in the middle is always going to be in between them. So in this case, that's where negative 5/3 is less than or equal to x, which is less than or equal to 1. Remember, the reason I have all of these equals on these inequalities is just because the original inequality up here had it as well. So we're just being consistent. All right, we need to pick an x value from each section. Don't feel obligated to use fractions. Don't use fractions, right? Pick nice numbers. So something bigger than 1 would probably be 2. Something in between negative 5/3 and positive 1, it'd probably be 0. And something smaller than negative 5/3, which is negative 1.67 if you don't know, I'd probably go with just negative 2. You could absolutely use like negative 5 or negative 10 if you really want to be safe. Totally up to you. All right, so we're going to plug these things in. So for my 3 sections, and again, you don't have to set this up quite so nicely. Just make sure you keep things organized. So when x is less than or equal to negative 5/3, we have x being negative 2 as our test point. Remember to plug it back into the original inequality. That's before we moved anything around. So this thing up here with the 2x on the right side. That's okay. We're not solving now, so we don't care if it's on the right side. We don't need it to equal 0. We want it to be back how it started. So we've got negative 3x squared plus 5 is less than or equal to 2x. And so if we plug negative 2 in there, and we calculate very carefully, let's see what happens. So negative 2 squared is 4. And 2 times negative 2 is negative 4. Remember, we're not solving, so we're not moving things back and forth here. We're just simplifying. So negative 3 times 4 is 12, or negative 12. And negative 12 plus 5 is negative 7. And hey, negative 7 is less than 4, so that's good. We like that. So we move on to our next point. So that's the in-between one, when negative 5/3 is less than or equal to x, which is less than or equal to 1. I picked 0 for that, and so that's going to be a lot easier to plug in. If we put 0 in for both of those x's, you can already see this is probably not going to work out super nicely. So negative 3 times 0 squared is just 0. So we've got 0 plus 5 is less than or equal to 0, which is 5 is less than or equal to 0. And we know that's not true. So this one is out. And then we test our section on the right, which is when x is greater than or equal to, not 0, 1. So we're going to plug in x equals 2. We got negative 3 times 2 squared plus 5 less than or equal to 2 times 2. So that's negative 3 times 4 plus 5 is less than or equal to 4. Negative 3 times 4 is negative 12. And this is just the same calculation we did last time, basically. So negative 12 plus 5 is negative 7. 2 times 2 is positive 4 this time instead of negative 4. But otherwise, we've ended up with still something that works, right? Negative 7 is less than or equal to positive 4. And so that is good. So this section on the right and this section on the left both got us things that we wanted. And so my solution is just the domains from those two sections. So it's this domain and this domain. And so my answer is x is less than or equal to negative 5 over 3, or x is greater than or equal to positive 1. And there we are. We could have kind of gotten a sense of this being the answer a little bit earlier if we had thought a little bit graphically. So we're not going to draw a real graph, but if we just sketch this out, something like this, we have x-intercepts at positive 1 and negative 5/3, something like that. And this graph, because our a value here is negative 3, is going to be opening downwards. And so we know we've got a graph that looks, something like this. Again, not too fussed about the specifics. We wanted this, if we looked at this stage, right? We wanted this to be less than 0, which means we wanted it to be below the axis. And so the same way we did in the 9.2.1 video, if we want to be below the axis, that means we want this part here and this part here, which is our two outside pieces, which is the exact same thing we figured out here. So the two methods are pretty much the same thing. It's just a different way of getting there. So if you're a more visual person, the graphing will typically be your best option. If you're a more numbers-driven person, this will be your best option. But they both work, and they'll both get you to the right place. One thing to think about when you're doing this, just in terms of your answers, not to give specific numbers, but you can always have really like a few specific kinds of options with your domains. So you could end up with the two outside pieces being good and the inside piece being bad, or the two outside pieces being bad and the inside piece being good. But you're never going to have something that looks like this, because that would require your graph to be doing something like this, where, okay, the left piece is above and the right piece is above, the middle piece is above, but then the right piece is below. That's not a parabola anymore, right? So the two outside pieces are always going to be the same, and the middle piece is always going to be opposite. So never, ever try to give an answer like this, or, I don't know, like this, or anything like that, where the middle matches one of the outside pieces, because that's just not going to be a thing. The only weird exceptions, we can get a few exceptions, is when the vertex is in a slightly different place. So if your vertex and your graph looks like this, because we know that can happen, if I asked you when this thing was less than 0, well, if you look at that graph, that's never less than 0. And so this one would have no solutions. There would be nothing that you could ever put into this that would make it be less than 0. If I asked you where it's greater than 0, well, that would be everything. Every x value would make that thing bigger than 0, because it's always above the axis. And so that's when we get the XER stuff. And it would be the opposite if we wanted it to be below the axis and it was pointing down and below. So something like this would kind of have the opposite answers. If I gave you something that was on the axis, then things get a little bit more interesting. So say we had something like this. So for this one here, we have an intercept, and I'm just going to say it's at negative 4. So if I asked you where this thing was greater than 0, well, if you look at this thing, if it's never above the axis, so this one is no solutions, never above the axis, never greater than 0. If I asked you where it was greater than or equal to 0, well, it is equal to 0 in one place. That's only going to happen when x is negative 4. If I asked you where it was less than 0, well, it's less than 0 everywhere except on that intercept, right? The intercept isn't below 0, the intercept is equal to 0. So that would be all real numbers except when x is negative 4. And then if I asked you when it was less than or equal to 0, that would just be all real numbers, because it's less than 0 everywhere except for the intercept, but the intercept is equal to 0. These are kind of like specific edge cases that we're not really going to run into much, but just know that there are some weird things that do strange things to your answers. Most of your answers, though, are going to look like the top two rows here. They're not going to look like those rows. Those rows are bad. Right? We don't want these. We get rid of those. But those top two rows is good. All right, let's end this off with a word problem. So give me a second to write this out, and then copy it down and see how you do. talk about it once it's down. All right, so we've got an equation here that connects height and time. And then we're asked, when is this gymnast going to be at least 6 meters in the air? So what we have to think about ourselves, so we've got our function, right? Negative 5t squared plus 10t plus 4. So this whole thing represents height. If you want to be at least 6 meters in the air, well, that means the other side of your inequality is going to be 6. Let's do that in a different color to make it really stand out. So if we want to be bigger than 6, you've got to ask yourself, which direction is this thing going to be facing? Is it going to look like that? Or is it going to look like this? Ignore everything on the left right now. I'm going to get rid of this whole thing. We'll bring it back in a sec. If you want to be at least 6, do you want to be bigger than 6 or smaller than 6? That means you want to be bigger than 6. So we really need to have this thing facing this way. We want something to be bigger than that 6 value. So don't get hung up on the words too much or what the function is. Think carefully about what it's telling you. If it says at least 6, you need to be bigger. And at least also leaves room for the option of it being equal. So this is what we're actually trying to solve here. So now we've got our inequality, and now we need to solve it. I'll tell you right now, this one is not going to have clean intercepts, so you're probably going to want to use the quadratic formula. So go ahead, use the quadratic formula, figure out where your x-intercepts are, do some testing, and see if you can figure out what your solution is. And then once you've done all of that and you've finished the whole question, come back and see how you made out. So before we can use the quadratic formula, we do have to make sure that 6 on the right side of our equation gets moved over to the left, right? So remember, when we're doing our inequalities, when we're solving for our x-intercepts, we do have to make sure that this thing equals to 0. So I'm going to subtract 6 on both sides here. And I'm going to get left with negative 5t squared plus 10t minus 2 is greater than or equal to 0. So now we want to use the quadratic formula, which is going to be t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. When we start plugging stuff in, that's going to be negative 10 plus or minus the square root of 10 squared minus 4 times negative 5 times negative 2 all over 2 times negative 5. We simplify a little bit, we get negative 10 plus or minus the square root of 100 minus 40 all over negative 10, which is negative 10 plus or minus the square root of 60 all over negative 10. We're not worried about exact values here, so we're just going to go straight to some solutions. So our intercepts are going to be at t equals 0.23 and t equals 1.77. All right. So if we make ourselves a number line, so we've got 0.23, we've got 1.77, and so we want to pick a number from each of those sections. So smaller than 0.23, well, your easiest thing is probably 0. In between those two things, your biggest thing or easiest thing is probably 1. And then on the right, you're probably going to go with 2. So our 3 domains, we've got the t values that are less than or equal to 0.23, the t values that are in between 0.23 and 1.77, and then everything that's bigger than 1.77. So for the left section, again, we're going to plug in t equals 0. For the right section, we're going to plug in t equals 2. And in the middle, we're going to plug in t equals 1. I'm not going to go through and show all of that just to speed up this video a little bit, but just to give you the quick rundown on the first one. So remember, we're going to plug this into our original function before we moved that 6 to the other side. If you forgot to move the 6, you're probably going to have run into some issues along the way here. So if you didn't do that, you might have to go back and redo everything. So we've got negative 5 times 0 squared plus 10 times 0 plus 4 greater than or equal to 6. So all those zeros are going to cancel out, and we're just going to be left with 4 is greater than or equal to 6. If you plug 1 into this, so you have negative 5 times 1 squared, which is negative 5, plus 10 times 1, which is positive 5. So all that together is going to get you plus 4 you'll have 9 is greater than or equal to 6. And if you plug 2 into there, you're also going to end up with 4 is greater than or equal to 6. And so if we look at those, the left section and the right section don't work, the middle section does. And so our domain is 0.23 is less than or equal to t, is less than or equal to 1.77. And so if we go back to answer our question, we get our final answer of he was above 6 meters between 0.23 seconds and 1.77 seconds. And so there you have it. That is how to solve these things without graphing. So again, we can still use graphing as sort of a guideline, but when you're doing it algebraically, it is just a lot of splitting things up, plugging numbers in, and testing. So if you're struggling, do make sure to get help. Go through this video a couple of times. It is a concept that does cause some people some trouble. Once you feel like you really got it nailed, feel free to move on to the next chapter.